conversation we are looking at having today is around the white paper that we've been working on. So basically, speaking about the TIWA FreeForm Agentic Architecture, one analogy that was discussed while writing this white paper was one similar to the human analogy, where we are looking at a human being. When a child is born, by default, the child is already programmed with certain capabilities, reasoning, communication, movements, right? Things like that. But then, based on the environment that the child finds themselves, this particular different layers or different capabilities are enhanced, right? And this is where the differentiation comes in. So adapting that to like agents, you have capabilities exposed to, basically what we are saying is that we have capabilities exposed to agents like OS access, libraries and frameworks, tools, runtime, and things like that. Ability to adopt, learn new things, right? Exposed to the agent. So the agent is able to pretty much move from that point and come up with solutions to any problem that's it's given, rather than being restricted while using the RTI model, right? Before going into what the freeform agentic architecture is all about, is this formal definition that basically looks at the task that the agents can solve is only possible if the solution to that task is expressed within the composition of the function f, right? And this is represented by this, that if that particular program is within the function exposed to the agent can solve that particular task.
So one of the things with freeform agentic architecture is not limiting the agent to abstraction, right? So yeah, and this give you the chance as an engineer building agent ability or chance to be able to focus more on securing your agent, do a lot of prompt engineering than coding the capability of the agent itself. So it is left for your prompt engineering to now do the security and a lot of your rail guard to be able to do a lot of things to protect the agent because we have to be very security conscious of freeform architecture, right? So our agent will not go rogue, right? But it gives your agent to be able to do anything. And what I want you to get is, if you follow freeform, if you are you are developing an agent for arts, whatever, perhaps content generation, you might already have a predefined function for generating graphics, right?
Yeah.
So when you build agent that you expect something, we tend to rely heavily on tools like Markdown for output of things, or use some basic internal tools, depends on how your architecture to maybe graphics design or designing something for user. But HTML rendering has proven a lot more better when it comes to agent or AI LLM models giving user output. So because in the browser, the HTML is native. You have to understand, is native to the browser. It's already in the DOM. So the output you have is just, how do I put it? It's just like you are rendering the page you have been on. But if you look at the way most of the LLMs or the agents you have nowadays, we heavily rely on Markdown, using Markdown to render output for users, not just in great content, but normal text that we read. And when you copy those texts and you see those sharp asterisk symbols, those are Markdown being rendered in real time, right? They still don't give you that quality output that you want, but HTML has proven that if content is rendered in the DOM, the agent literally have access to every design output you could possibly imagine. You can use CSS, you can use JavaScript, you can use Tailwind CSS if that is what you want to embed in your agent. for you to have this beautiful output from your agent. So one of the things HTML rendering, native rendering brings to agents in terms of rendering is not just at the level of just displaying content. It's at the level of speed. How fast is it? Your user gets their response, right? So HTML is native, as we said. And then what is the quality of that output? Is it high quality or some kind of weird content looking that users have to end up formatting, or try to tell the agent why don't make that text become bigger, make that one, which the agent will be going up and down on the markdown, trying to make it your standards and all of that. So these are one of the basic elements of using HNRA inside a freeform agentic architecture.
Yeah, so I think you already touched on the different layers, starting from the OS capability exposure to the dynamic computational reasoning, and also the HTML native rendering architecture, which basically looks at direct DOM level output production, right? And also touching on adaptive tool orchestration, which freeform agentic architecture gives us access to, right?
I'm
Yeah, I
okay.
was going to say this is where we are going to stop this conversation, right? Because it's basically to build some form of anticipation in terms of what we'll be talking about next, about agentic traffic optimization, designing platforms that can serve both humans and autonomous AI consumers.